Precision agriculture. Precision agriculture is a management strategy that is used for gathering, processing, and analyzing temporal, spatial, and individual data. This data is then used to make agronomic recommendations to improve efficiency, productivity, quality, sustainability, and profitability of agricultural production. One application that utilizes data from satellites and lends to precision farming is remote sensing. Some main sources of data for precision agriculture is from satellite-based technologies such as GPS and GIS. Remote sensing studies reflectance and is usually used to detect and measure electromagnetic energy, including visible and non-visible radiation. Multispectral and hyperspectral sensors produce images consisting of reflectance data from the visible, near-infrared, and mid-infrared regions of the electromagnetic spectrum. Now, what does this mean exactly? In layman's terms, hyperspectral and multispectral images contain information outlining frequencies of the electromagnetic spectrum that is not visible to the naked eye. For example, a regular camera captures light in 3 different wavelength bands: red, green, and blue. Spectral imaging sensors capture multiple bands across the electromagnetic spectrum. Utilizing specialized software, the spectral information can be manipulated to a format that is interpretable. This format is the image with varying colors and can be interpreted in terms of physical parameters. Physical parameters include crop cover, crop health, and soil moisture, which are useful in operations such as stress mapping, application pesticide, application of fertilizer, and management of irrigation. Pros of remote sensing. Remote sensing provides integral data to the agricultural community by identifying which inputs are required where, at what time, and in what amounts. Remote sensing is applicable to farms of varying sizes: small, medium, and large-scale agricultural corporations. Remote sensing presents numerous useful applications, such as monitoring vegetation cover, crop production forecasting, assessment of crop condition, crop identification, identification of pests and diseases, soil moisture estimation, water resource management. Cons of remote sensing. One of the biggest disadvantages of remote sensing is its costs. It is costly to analyze repetitive photographs if there is need to analyze different aspects of the same features. Remote sensing requires specialized training to analyze spectral imagery. This training adds to the overall cost. Remote sensing instruments can hinder its own performance. Remote sensing radars emit radiation, which can be intrusive to the investigated phenomena. This information presented by remote sensing may be temporary.